Hey folks, welcome to another C++ tutorial chapter. This time we're going to be talking about functions. As you know, in C++ we have two kinds of functions. There's the built-in functions, and we've seen those in prior podcasts and prior videos and my series of my tutorial. And most notably, we'll be using the get line, or the the printf in case of the C, or math, right? Like square roots and absolute numbers and logarithmic numbers and all that. So mostly it's in math, but again, the printf or the get line, those are functions. Those are built-in functions in C++. So, or they're given to us by the creators of this, right? So anyways, today we're going to be concentrating on user-defined functions, the ones we create. That's what makes this one of the features that makes C++ very powerful. In C++, everything is a function. It's one of the main characteristics. In fact, the program starts with the function main. It could be void main and no arguments, or it could be int main and return a value. Normally we return 0, of course, but I'll explain this more in detail in my first example right after this short PowerPoint. Another distinguished things between C++ and most notably between C++ and Pascal or BASIC is that in C++ everything is a function. In Pascal and in Quick Basic and all that, you have procedures and you have functions. And the difference between a procedure and a function is that a function returns a value where a procedure did not. Not including, of course, the parameters that could be sent by reference or by value. And we'll talk about those. But in C++, they say, you know what? Everything is a function. We don't have procedures. If you want a function that doesn't return anything, use the void. Void is a keyword that we can put in front of a function, say void, and then the function name, and then parameters if they're sending and all that. And it won't. You don't have to do a return statement. It is not a good practice to do it, but yes, it will work. In fact, I will do that as an example. One of my first examples. I have several quick examples. So anyways, the general format of a function in C++ is you have the variable type. It could be int, bool for boolean, it could be string, it could be void. So you have, when you put void, you automatically making it a procedure, not a function, but it's just a returnless function, right? And then you have the function name, and then you have their parameters, which are optional. You don't have to have them, but you can have them. Inside a function, the function always has the brackets. The brackets are right here, and that's a requirement. Unlike other things like the for loop or the do loop or all that, where you can have one statement. Here you always have the brackets and you have a series of statements. And if the var type is anything other than void, you have a return statement, and then the value here will have to match this. So if I have int main nothing, do my statements, return 0 or 1 or 2 or whatever I want. Normally we do return 0 if everything's okay. So that is the general format of a function. And so here we are, the value of the function. Var type is the value the function will return. The name, the parameters are optional. The statements, and the value that it will return. Again, the type value must be the same that you're declaring the function, or you will get an error. 3 things to remember. You gotta declare the function. You gotta use the actual function, and then you call the function. So one thing I gotta note here, is this here declaring the function a requirement? It is good programming to do so. If the function is typed prior to where it's being called from, you don't have to declare it. So because main can be anywhere in the program, there's no rule on that in C++. You can have 3 functions and then main and another 3 functions afterwards, and the program's automatically going to go to main. But let's say one of the 3 functions in the beginning, let's say 1, 2, and 3, main, and 4, 5, and 6. When I get to main, the first thing I call is 1 or 2. I don't have to declare the function because C++ is going to see that it's there. On the other hand, if I call 4, 5, and 6, and I have not declared the function, I'm going to get an error. So good programming, just declare the function. It doesn't matter if it's there at the beginning or at the end. Near the beginning of the program, let's declare our function. And the format is this, the value, the function, and then inside, if there's any parameters, if there's no parameters, we put the parentheses. If they are parameters, we just put the values like in, comma, double, comma, sharp, comma, double, comma, in the order that are being called. Now, the function itself will be very similar to this, int, my function. Now here, I will put the actual variable name, int, and the number. And if I had int, comma, int, comma, int, here I've had int num, comma, int num, comma, int num. I will have my brackets. Again, these are required and all that. Now the name here, num, in this case, is gonna, inside the function, is gonna have the value that I'm sending in as a parameter, right? So this will match, except when I'm declaring it and not putting the name of the variable, only the type. Now, whenever I'm calling the function, and by the way, I can call the function from wherever I want. I don't have to be in another function. It could be anywhere. Then I can say, since this is of type int a, remember I can declare int anywhere, equals my function, and then I'm sending the parameter 5, which num, at that point, I will go to this function and num equals 5, okay? And I'm gonna do some programs here, but this is small 4-slide PowerPoint just to show you what I'm gonna be talking about. So declare the function, the actual function, and how you use the function to call it from wherever you're calling it from. Other things that I will cover in this video, the scope of the variables, local versus global, and why it's not a good idea to call everything the same thing, and why we use capitals for constants and all that. I will cover all that. Static variables, these I will talk more about them, but basically static variable is it allows the function to keep the value of the variables inside the function, because otherwise, normally the value of a variable in a function is only while the function is working. Once you leave, it gets reset. But with this, I can make it stay. And I'm going to do an example about using static, how force the function to keep the values. The default values, that's when you declare a function that has parameters, but if I call the function without parameters, what happens? Well, I don't get an error, but you can always have a default values that would do it instead of. Overloading, the basic way of declaring overloading or to state what overloading is, basically when you have the same name of a function on multiple functions. And I'm going to use a quick example of area. Maybe I want to calculate the area of a circle, a triangle, a rectangle. But what do? Do you make one function with 5 parameters where some are ignored and the first one declares what type of function it is? Or can I just do 3 functions, each one for a different one of the areas with different parameters, one with 1 parameter, one with 2 parameters, one with 3 parameters, and so on? Or maybe they're different types of parameters. Maybe it's the square root. If both numbers are integers, let's say 25, it returns a 5. But if it's a double, then it's from 25.0 to 5.0, right? So I can have the same function with different types of variable types, from ints to doubles to floats, etc. So that's overloading. And then briefly, we'll talk about the exit function, which is, I use it sometimes. I don't always use it. The normal thing should be not to use it, but it is there, and we will cover that as well. This is just a brief introduction of what I will be covering. I have multiple videos. They're very simple. I'm going to be using one file, and I'm just going to modify it over and over. And I will cover each one of these things in the functions. And hopefully you'll understand how functions work in C++. One thing I will not cover here in functions is pointers, because we will eventually get to pointers. in its own video. It will be a video as its own. So, but just so you know, you can send just about anything to a function. So let's get to it. Okay, guys, so here we are in the hands-on explanation of functions in C++. The one thing to remember, well, there's multiple things to remember here, but first things first, right off the bat, the function main is always the one that is called first in C++. You always need, all functions are optional except this one. This is a required function and it's a type int. So you got to return some value. You can return any value you want, but it has to be a type integer. Usually we use return 0, no errors, everything is fine. So that's right off the bat. They are, of course, the whole purpose of a function is to block multiple things together, put them all in a block, and then you can repeat that block as many times as you want and not having to retype the whole thing, right? So that's the whole point. Now, as I mentioned, main is the main thing here, but C++ will give us built-in functions. Some of them are like getLine, which I've used in prior examples to capture a whole line of text. That's a function it's given to us. I'm going to use CMath. Here's my include CMath, and I'm going to do some built-in functions because math is where most of the functions are in C++, the ones that are included anyways. Not all of them are there, but a good chunk of them, at least for explanation purposes. Once I've included CMath, I can do things like cout, and I can do the minimum of 3 and 7. I can cout the square root of 49. I can cout the absolute value of -15. And I don't know, the list goes on. I'm going to do only these 3 just to show these. And here they are, the smallest number of 3 and 7 is 3, the square root of 49 is 7, and the absolute of -15 is 15. So these are built-in functions right here, min, square root, and absolute, right? And there's many more. After I'm done with the tutorial on C++, I'm going to probably work on a tutorial of all the built-in math functions that C++ has, which is just a bunch of them. So that's the first thing. I'm going to go ahead and get rid of CMath because I just wanted to explain how, show how there is functions in math that are already included, given to us by default, which is pretty awesome. Now let's talk about the prototype. Now, by default, like I said, there's main. Main has all the parts of a function, the return value, the name. There's no parameters, but if there were, we could put them there. And the return, if there is any. If it was a type void, we wouldn't need that. But let's say I have a function and my function is void. It's not going to return any value. So I'm going to do p message and it's not going to have any parameters. This is the declaration. This is what they call a prototype. I call it declaration because I'm declaring my function, but it's called a prototype. That's the correct name, prototype. Now, I can go here and call p message. That's how I would do it because there's no parameters. And then underneath I can do void p message cout hello world. And there it is. So I have my prototype. I'm calling the function, and here is my function. So let's run this, and here is hello world. Now, do I need to do the prototype? Well, yes and no. Let's say instead of doing the prototype, I put my function in the beginning. So I'm going to do it right here. So I'm not going to do a prototype. I'm just going to put p message before main. Is it going to work? Absolutely, it is going to work. However, if I put it underneath main, see, I still get that error message, undeclare p message. So I gotta do void p message and I'm telling C++ that p message is out there somewhere. Now, if it's a small program like this, you can see in front of you, oh, well, p message is above it. I don't have to declare it. It's optional. And you're right. But what if you have hundreds of functions? Remember, one of the main things about C++ and any other program that you do functions and procedures is that you want to do small chunks of code and then have a bunch of functions, right? You don't want functions, imagine a program with 3 functions and each one has 15,000 lines. Well, what's the point? It's about as complex as the other main program. So you want to make as many functions and procedures as you want. Now, I say procedures, basically in C++, a procedure is nothing but a function with the value void. If you think about it in Pascal or BASIC, a sub will do something and not return a value while a function will. Here, we just say void and it's the same thing. They went around it like that, which was very awesome. Now, I'm going to do p message and I'm going to do another one. I'm going to call it p string. And why am I doing that? Well, I'm going to say p string, well, void, right? Void. P message. Now, notice what I'm doing right here. And then over here, I'm going to do p string. So I've declared 2 functions, p message and p string. My main goes and says, hey, do p string. It jumps to p string and it says, do p message. It goes to p message and it counts hello world. I do this here, and there it is, my hello world. So what is all this for? Basically, a function could be called from anywhere in the program. And if that's why it's recommended that you do the prototype of your functions in the beginning of the program, then it doesn't matter where you are in the program. It's going to keep calling the program and it's going to be okay. So that will work just fine. Now, so far we had declared void functions with no parameters. What if I wanted to do something that returns a value? So I'm going to declare something int add a number, and I'm going to give it a parameter. I'm going to say it's an int, and I'm going to actually do 2 int. There we go. I have did the prototype for a function. The name is add a number. It is of type int, and it requires 2 parameters. Now here, I'm going to say int a equals 4, b equals 6. So I've declared 2 variables, and then I'm going to say, oh, of course, and I need c, right? So I'm going to say c equals add a number, and I'm going to say a comma b. C out, C and L. There we go. Now let's go down here. Doesn't matter where, I'm just going to add it right here. So I'm going to do int add a number. I'm going to do multiple things in this one function. Int x, int y, and then I'm going to say int z equals x plus y, and return z. All these things I've done, I gotta explain all these things. First of all, this function has a value of int. it must return a value. Second thing, I got two ints right here. So now I got parameters, two of them to be exact. These could be int, bool, string. I mean, anything that you can declare as a variable. Of course, I have to include string to the string. I can do char, I can do pointers. I'm not gonna do any of that right now, but basically, I can, whatever I put here, this function is requiring it. Now I'm saying, hey, there's A, B, and C here. A is 4 and B is 6. I'm initializing the values right out the back. Um, and I'm saying C equals my function. Now, how do I know C is going to be doing? Because C is supposed to return an int value. So C will return, will be the function, and I'm sending A and B, and then I'm printing C. But if we go down here, now I'm not just saying int, now I'm saying int in the X and Y. So the first value here, which is 4, X will be equals to 4. And then B here is, I'm sorry, yeah, B is 6. So now Y is going to be 6. I'm adding them up and I'm returning this value and it's going back into C. So this is how that looks. So I'm adding those two values. Could I've done here 4 and 6? Well, yeah, I could have. Let's do it. There it is, same value. So I could put in the value or I could put in the variable name. Either way, I can put in here B. And will it work? Well, should work because B equals C. So that's how this works. Now, let's assume that we want to have a value that does not change. Now, I'm instead of int Z, well, actually int Z, we'll leave that one alone. I'm gonna see out here something. I'm going to see out int W equals 7 and see out W and line. I'm just saying W equals 7, see out W, and there's my 7. Okay, now I'm gonna say, I'm gonna go here and I'm going to do for int I equals 1, I less than equal to 5, I plus plus, and I'm going to move these here. So 5 times I'm going to do this, 5 times. So let's do this here and I'm gonna move this up, and there it is, 710, 710, 710, 710, 710. That is it, the value of a local variable. The value of a variable will stay within the function until the function ends. Once it returns, it erases the value. But what if this W, instead of doing that, I do static int W, and it's going to initialize to 0. Or it should initialize to 0. And then I'm going to do this right here. I'm going to increase the value of W. Now remember, when I didn't have the word static, W was initialized to whatever I told it to. But now that I have this, check it out, 0, 1, 2, 3, and 4. Why is it doing that? Well, right, first of all, since I'm not giving it a value here, it's automatically initializing to 0. That's one thing. Second of all, it's incrementing the value of W and it's keeping it. What if I do equals 5? Let's do that. And I want you to see this 5, 6, 7, 8, and 9. So what C++ is doing, it's initializing the value to 5, but then because it's of type static, the first time it initializes, the second time and so on, it's going to do whatever the program tells it to. So I'm incrementing by 1 right there. That's what the static word does. Now, just like static is required for functions to keep the values, const, C-O-N-S-T, is required for variables to keep the names. Usually, if you want a variable to be available everywhere, because remember, A, B, and C here are not available over here. In fact, if I put here C out A, it's not gonna print 4. I'll tell you that right now. But I could declare a constant over here, then it'll be available everywhere. So let's do that. Let's go here and do const int, and I'm gonna do capital X equals 10. And I'm just gonna go to my P message, and I'm gonna do C out X. Okay. So now when I go and I do run, and I'm gonna see this, there's my 10, hello world, 510, 5610, 710, 810, 810. So that maybe just make it so I'm gonna do 12, okay? Just so we can see the difference because it's the same as the other one. And there it is. There's my 12, hello world, and then I go 510, 5610. Because I'm at, let's remember this other tense is from adding 4 and 6. So when it's a const variable right here, const and then and that usually we do capitals. Is it required? No, remember it's not case sensitive in C++, but I do recommend that you use capital so you know the constants. Now X capital is going to be available anywhere in any function with the value that I've given it. Otherwise, all the variables are local to the function or the procedure. Like here, this I here equals this, but if I print it out over here, it's not gonna, it doesn't even know where I is. It doesn't even know what it is. So another thing that we need on is the default values. Now, if there's no initializing declaration of a function like I do here, this over here can be overridden with a default value. So let's say I'm doing int. Well, let's not. Yeah, let's do this one. Let's say I'm saying int add a number, and then I'm going to say int equals 5, int equals 5. So I'm going to add a number, and then I'm going to see out add a number without values. And I gotta put this here like that. And I'm gonna do /tab. I'm gonna see out. I'm gonna say C equals add a number and C out C and line. So what have I done? Okay, first of all, I'm giving it an initial value of 5 and 5. This is optional and it will only work if you don't submit a value. Like here, I'm doing X and Y. So that's why I'm getting all the 10s down here, right? But what if I didn't supply a number? Well, then it assumes that the initial value is 5. And it's gonna do 10, so it's not gonna, you're not gonna see the difference. So I'm gonna do 8 and 8. I just thought about that. Okay, so let's do this now. So this is what my program looks like. Here's the 12 from, that's my 12. Then the 12 comes from right there, X, remember? My const, that's where the 12. Then it says hello world. There's my hello world right there. Then it does the add a number, and I have 510, 610, 710, 810, and 910. But if I add them without values, it's 16. Because if I don't use values, it goes to the initial values of 8 and 8. So that's why, so now let's do I'm gonna get rid of these p strings and p messages. I'm gonna go work strict with that. I'm gonna get rid of these two over here. Make the program a little shorter, only for demonstration. I'm gonna get rid of my const. I don't need it. And I'll leave my function there because I will be using my function of add a number. But I'm gonna do something different actually. I'm gonna completely get rid of this function here and get rid of it over here, of course. All right, so far so good. And I'm gonna erase all of that. All right, so we're back to square one. There's one more thing I wanna do. Well, there's two things I wanna do before I end this video. The first one is called overloading. Overloading. Let's say I have a double. Well, double, and I'm gonna say A, B, and C. And A is gonna be equal to 1, B is gonna be equal to 2, and C is gonna be equal to 3. So far, so good. I'm gonna do a double area where I'm asking for a double. Now let's say the area of a circle. I want to calculate the area of a circle, okay? I'm gonna go ahead and go over here, double area, double X. And then I'm gonna do this, and I'm gonna say C out. Maybe I'm gonna do double val. And val will be equals to X times 3.1416, right? And gotta make sure I put that in there. And then I'm gonna return area, val. What am I thinking about? Okay, so I'm gonna go to my main program and I'm gonna say, look, C out area of a circle is, and I'm going to say, I need a double B, double val. Do that. Sticky fingers. I always have sticky fingers. So val equals area, and I'm gonna say, let's say B. C out, B, and line. So what am I doing? Well, I'm saying, look, there's a function named area. It returns a value of double. It requires a double. Area gets double, gives it to X. Value equals X times 3.14 and returns value. That's the area of a circle. So now I'm saying, what is the circle? Let's say I'm using the value of B in this case. I'm not using A or B or C at this point. Actually, yeah, I'm not gonna use it. And then I'm displaying it. So area of our circle is 2, right? Why is it doing that? This is a tricky question. How about that? There we go. Here's the area of a circle, 12.56. If I'm using 2, the area of a circle will be 12.56 right here, because that's what my formula is. Now, I went through all this trouble because I want to make a point. What if I wanted to say use another, I could do the name of, call this circle area. I could do that. And then I can do a double rectangle area. Double, right? Could do that. But what if I wanted to use the same one? the same name. Well, I can do that. This is called overloading. One requires one, the other one requires two. So I'm going to copy this and I'm going to call this double area, double X, double Y. And now I'm going to say is X times Y. And I'm going to return value. Now, check this out. Area of a rectangle. Rectangle is, and I'm going to say B, comma, C. So I'm sending B and C. I'm not using A at all. I thought I was going to use it. See, this has the same name, area with one variable, one parameter, and then area with two parameters. And both do different things, but they both return a value. Doesn't matter. So now I'm going to do run. And here's the area of a circle. Here's the area of a rectangle, 6. Because I'm using 2 and 3. And that's called overloading. Overloading is when you have multiple functions that can receive different types of parameters. And that's what that is. So far, I've showed you how to do multiple functions, how to return the value of a function. We've seen how we can have prototypes, initial values. Not bad, right? And then this was overloading. There is one more thing I want to show you. Oh, looking at my notes here. Obviously, if there's a return, if there's a value, if there wasn't, like I had on P message, obviously it would be a void, right? The void will return absolutely nothing, which makes it the same as a procedure, a sub in BASIC. Okay, so now let's assume I wanted to send a variable and I want that variable to be able to be changed. Remember, no matter what I send, I'm gonna go ahead and get rid of my value here. And I'm gonna get rid of this one over here. So far, so good. I never actually used be A, but I'm gonna go ahead and leave A now. And then get rid of this. So far, so good. Let me see. Nope. What did I missing? Oh, of course. It's A. I got rid of it. That's the area of a circle. There is something else, and it's called. We looked at the static variables, default variables. Now, let's talk about something. My final thing here, called reference variables. A reference variable is something that can be changed by the function. So instead of doing area double here, I'm gonna say double, and then I'm gonna put the ampersand. Now this changes things. I'm gonna put an ampersand over here. And so double the ampersand. This is by reference, okay? And I'm gonna put the ampersand over here. And I'm going to go ahead and do my function is going to be ampersand x as well. Actually, I don't need to. I'm going to put an A here. Now, what is the difference? Well, let's say that x, make x equals 25. And over here, see out A. But before I do that, I'm going to see out A. Okay, so A equals 1. No, let's back up a little. Double area, and I have an ampersand right there. That means I'm sending it by reference. Now I'm saying A equals 1. I'm printing the value of 1. I'm calculating the circle, printing the variable, and now I'm printing A again. But when I go to my function, here's my ampersand again. I'm changing the value of x to 25. Okay, so look what's going to happen. First, it equals to 1. There's my 1 right there. And it prints it out. There's my 1. Then I call the function and I'm getting the value. Value is 3.1415 because I'm multiplying 1 times 1 times pi. But then when I print A, now equals 25. That's because over here I said x equals 25. This is sending a variable by reference. When you use the ampersand and then over here the ampersand, if I change the value of this variable here, of the parameter, it will change it back wherever it was coming from. And that's called by reference. That's called by reference. Finally, the one last thing I want to do, check this out. Before I return here, I'm going to do exit 0. I know you're probably saying exit 0. What's it going to do? Check it out. Yep. The process finished with exit code 0. There's my 0 right there. The area of a circle, see it did this, the 1, the area of a circle right there. Then I went over here, but before I return it, I ended my program. So the program ended, and that's the exit function. The exit can exit the program no matter where you are, and you can send an optional parameter there, right there. You see it's declared an stdlib. Okay, I think I got everything covered. Functions, parameters, by reference or by value, overloading, return codes, declaration. More examples to come with my next tutorial. Anyways, I hope you enjoyed this. If you like this video, you know what to do. Please click and subscribe. All right. Thank you very much.